And we are live here for another episode of AWS Howdy Partner Twitch show. I'm your host, Jeong. I am from AWS. I am a partner solutions architect. Here to host with me is Rob Melka.
Thanks, Jeong. Hello, everyone. Rob Melka here. Like Jeong, I'm a partner solutions architect with the AWS Partner Network. I'm based out of Seattle, Washington, and I help a global network of AWS consulting and technology partners.
And in the background, you can't see, but we have our operator, Braden, in his secret hideaway. Thanks, Braden, for being our operator today so that we can run this awesome show. With us, with Rob and I, are the folks from Tenable, Tim and Will. You just want to say hello to everyone out there, Tim and Will?
What's up, guys? Pleasure to be here. Tim Morsey on the Tenable side. Been with Tenable for about 3 years. Happy to be partnering with you guys and bringing you the show today.
Hey guys, Will Palm from Tenable as well. I'm a solutions architect on our team for specializing in application security. Looking forward to it.
Sounds great. And we'll get to you guys in a little bit. We have an awesome show coming up, and I think as an audience, you will love what they will have to present in a few minutes. But Rob, tell our audience about the show itself. What is Howdy Partner, and what are we doing here?
All right, so Howdy Partner is basically a show dedicated for AWS developer community. We help our developer community understand the partner products and solutions available to help you with your help you architect your workloads. And today with Tenable, we're going to touch on how we address the security needs of your organization and the different challenges that Tenable helps you resolve.
Sounds good. So as an audience, if you have any questions, you have the chat available with you. We will be monitoring it. So throw it in those questions as soon as you come up with them. But with that said, today we're going to talk about all things security. So Rob, did you have something you wanted to share to kick us off?
Yes. Thanks, Jeong. To kick us off, we'll start a bit of a walkthrough on our AWS well-architected framework and how it relates to the topics that we're going to be discussing today. So essentially, when we think about creating technology solutions, we're thinking of it's kind of similar to constructing a physical building. So if the foundation is not solid, it may cause structural problems that undermine the integrity and function of the building. So the AWS well-architected helps cloud architects and not only cloud architects, but developers as well, because security is a shared responsibility and everybody's a stakeholder. Helps them basically build secure, high-performing, resilient, and efficient infrastructure for their applications and workloads. So if you neglect any of the 5 pillars we're looking at right here, these are pillars on security, reliability, performance efficiency, cost optimization, and operational excellence. When architecting these solutions, it can become a challenge to basically build systems that deliver functional requirements that meet your expectations and your customers' needs. So when you incorporate these pillars, you're ensuring that you produce stable and efficient systems, allowing you to focus on functional requirements. So let's get into that. And next slide. All right, so generally speaking, with the well-architected framework, we have general design principles and we have pillar-specific design principles. So design principles help you adopt the appropriate mental model when building for the cloud, ensuring you take advantage of capabilities of AWS and free yourself from the constraints of traditional approaches. And to to think about it a little more concretely, we want to look at the general design principles. Some of these include testing systems at production scale, allowing for evolutionary architectures, and basically automating to make architectural experimentation easier. So this can be leveraging solutions like control tower or landing zone, basically allowing you to spin up baselined environments, multi-account environments much faster with the guardrails and compliance needs that your organizations might need. And then we have pillar-specific design principles. As you can see here, there's a security pillar-specific design principle, which is enabling traceability. And generally for the security-specific design principles, we're looking at implementing a strong identity foundation, enabling traceability, which includes monitoring, alerting, applying security at all layers. This is the principle of incorporating defense in depth. So security is not only at the perimeter, but also throughout the stack, and ensuring that you have that implemented across the board. And then also automating security best practices. And that is what we're going to be touching on today, which is specifically the security pillar and some of these security-specific design principles. And at any time, if you have any questions regarding topics we're discussing today, please feel free to drop a message and we'll definitely answer that. All right, so when we think about addressing
Rob.
some of these needs, go ahead.
Looks like your slides are frozen.
Oh, they are? Oh,
or
yeah.
At least the transition appears to be.
Maybe I am going a little bit too fast. Let me slow down a bit. Let me move back. Okay, let me stop and start, maybe. Maybe that'll help. What about now?
Still appears to be broken.
Okay. Let me just stop and share again. All right.
Sorry for the technical difficulties. I think that looks better. Yeah.
All right. So this is going to be brief. I don't want to, kill you all with, death by PowerPoint. We're going to, demo this shortly, but I just wanted to give you an overview of how we address some of these security-specific pillar design principles. So specifically on enabling traceability, you enable the data sources that Security Hub supports. So with Security Hub, you have a solution that helps you aggregate findings from multiple sources, whether it be AWS services like GuardDuty, CloudTrail, Amazon Macie, and many others, or partner solutions, which we'll get into later. But essentially that consolidates that for you in for your multi-account environments, and it basically brings it all in one pane of glass. So this gives you a holistic view of your security posture across your AWS environment. So you're continuously aggregating and prioritizing findings. I think the slides are not okay. There seems to be some delay on the transitions, but yeah, essentially we're trying to bring visibility of all these findings aggregated in one location and prioritizing them for for compliance checking and subsequently actions which can be fired off to automatically remediate or just alert you via your ticketing systems or via like an SNS topic. So let's jump straight into how this actually works. So this is, the next slide is not actually showing, so I'm just gonna stop my screen share and show you this on the console. Let me end the slide.
I think everything was just going so perfectly, so there had to be a
Yeah,
hiccup every now and then.
indeed, and that's the fun of. All right, can we? Let's stop that screen share. Share screen. All right. So yeah, you should see a console now. I'm on the AWS Management console, and I'm trying to address one of the prerequisites, which is having AWS config enabled in the region that I want to enable Security Hub in. And you can do this across your entire organization, since there's pretty seamless integration with the AWS organizations. And this is typically also addressed in a multi-account deployment using services like AWS Control Tower, which creates a separate account dedicated for security, which will have the security manager account for your entire organization in the security account, where you perform your security functions, and this will have a consolidated view of all those findings. So what we're doing now is we're enabling config really quickly.
Looks like your screen is still kind of breaking.
Frozen.
Yeah.
Okay. Yeah, it seems to be dragging on. Apologies there, but essentially what I'm doing here is I'm enabling AWS config, which is now enabled. And it'll take some time for findings to show up, including like a resource inventory of the resources that exist within this region. AWS config is region specific, so is Security Hub. So I am now on the Security Hub console, which is slowly loading. Again, apologies for that delay. And then I click on go to Security Hub.
You may just want to share and unshare once again, because I think it might be connection issues. I think there's some delay there.
Yeah, actually, let me see if that is the case. Hello?
Yep.
Can you see it now?
No, I think it's still, yeah, it's still.
All right, so maybe let me go to a different browser altogether. That might be it. All right. Okay, so actually, it seems to be loading.
Security Hub is showing parts of it anyways, but I think.
Okay, so let's yeah. The security standards are what we are focusing on right now. We have a couple options here with security standards. You have the AWS Foundational Security Best Practices, which is basically a set of best practices that we've compiled. This includes, best practices for various services like S3, EC2, and various others to help our customers get alerted on resources that are outside of compliance against those best practices. This is a great one to enable on initial creation. And depending on your requirements, you can also include the CIS benchmark security standard. Additionally, we have the PCI DSS, which is for organizations that have compliance standards that they need to meet, in this case, PCI. So we're just going to enable CIS and AWS foundational best practices. And then after enabling that, that'll take some time to load, and we'll touch on that once that's complete. But essentially, what we're trying to do is bring visibility to the Security Hub console, to the customer, by retrieving findings from various AWS services, and then taking actions accordingly based on what we've detected. So there are key best practices for security in the cloud, and there are 6 to be specific. One being security, second being identity and access management, third being detection, which Security Hub helps you address detection and response with various services that it integrates with. And then we have infrastructure protection, data protection, and then incident response. For a more comprehensive breakdown on these best practices and how we help you address them, you can look at our AWS well-architected white paper, which goes into detail of what we've discussed. So we'll touch base on the findings we see here and integrations that we have with our AWS partners like Tenable towards the end. And if you have any questions, please feel free to let us know. But for now, we have Tenable joining us, and Tim and Will go into the specifics of how their Tenable product suite help you address some of these best practices in the AWS cloud. And without further ado, Tim.
Yeah, sure. Thanks, Rob. So, hi, everyone. Thanks again. My name is Tim Morsey. Like I said, I'm a security engineer with Tenable. Been here for about 3 years, but I've been in the vulnerability management space and the security space my entire career. I won't tell how long that is, but I got a few more grays as a part of it, so that's okay. And yes, this is my real hair, believe it or not. My kids love messing with it. But yeah, so happy to be here. Happy to be talking with you guys a little bit about security, especially Tenable and the great partnership that we have with AWS. And with that, I'm going to start sharing my screen a little bit. Hopefully you guys can all see that okay. Cool. So just to kind of jump into it a little bit, what we're mainly going to be talking about today is just how to secure your infrastructure with AWS and Tenable. Obviously, my name is Tim Morsey. With me, I have my partner in crime, Will Palm. Will, do you want to say hey to everybody?
Hey, guys.
Cool. So Will's going to do some really cool deep dives into the web app security space, which is a really interesting space. And I'm going to primarily be focusing on the infrastructure side. So any type of EC2 instance, anything that you spin up in AWS, how you can scan it, how you can assess it, and really kind of getting back to Rob's point, what that looks like from a secure perspective, right? We talk about the security pillars. I always liken security to, before it was way back when it was like something that it was the checkbox, right? You had to do it. But now more and more organizations really realize that it's an enabler to their business. And if you don't do security well, kind of as Rob was indicating, as one of those core pillars, right? It's like trying to run with your shoes tied. You're going to trip, you're going to fall, and inevitably you're probably going to get popped. So we try to enable organizations as much as possible to really go deep into security, assess their network for vulnerabilities, patch them ahead of potential exploit, and really get a good footprint on what we call cyber exposure across their network. So what is their risk? What does that look like? And obviously, Tenable and AWS was a natural partnership because more and more people more and more organizations are moving their workloads to AWS and have a cloud presence. I talk to a lot of customers on a daily basis, and everyone's in different boats, right? Some are all in on-prem, some are all in on cloud, and many are kind of in between, where it's a hybrid situation. They have an on-prem infrastructure, but maybe moving workloads strategically to the cloud. So Tenable and AWS have had a strategic partnership. The platform we'll be in today, obviously, is Tenable.io. It's actually built in AWS. So customers that are Tenable.io customers get to enjoy the 99.95% uptime that AWS provides because all our infrastructure is hosted there. So as you guys will see as we go through this, it's super cloud friendly. And that's by design because we know more and more people are moving more close to the cloud. And they're all asking the same question, right? Like, how do we secure this? What does this look like? So that's what we're going to be focusing on today. We're going to walk through a couple different examples. We're going to get into the platform and just show you different ways to do it. And you might be asking, why so many ways? This is a recurring theme, right? It's not to confuse you. It's really just to give you a lot of flexibility. So everyone's cloud infrastructure, right? Even that looks different from organization to organization. And they might need different tools to do the job. So that's what we're going to be talking through today. How to scan using an AMI image in AWS. That's probably the most simple example that we'll walk through. The second is how to use agents in AWS. So script out an agent, deploy that to an EC2 instance. And then finally, the third is what we're most excited about. We just released it last, I think it's Q4 of 2020, is frictionless assessment, which is like completely agentless, no infrastructure whatsoever, and really, really good for kind of dynamic workloads or EC2 instances that may be spun up very quickly or dynamically. And then finally, last but not least, Will's going to get into a little bit about integrating Tenable into the AWS code build pipeline and just show you some practical examples that you could take away, you could use to do things like automated UAT test scripts and web application scanning. So what the heck does this look like, right? We get this question a lot. Tenable.io is a SaaS-based solution, so it lives in the cloud. But we integrate, obviously, with AWS. And you can, if you go out in the marketplace, you'll see where we're gonna start. If you do a quick search on Tenable, you'll find that we have a BYOL license and a pre-auth license. So that's where I'm gonna pivot over to real fast. Basically, both of these are accessible in the AWS marketplace. They're pre-built Linux AMIs. There's a Linux kind of CentOS and RHEL instance that's the underlying OS framework. And really, it's just helping you guys because it's providing lower cost of ownership. It's already pre-built for you. So literally, come out to AWS Marketplace. You can come out here anytime. Just do a quick search on Tenable.
Tim, maybe you can zoom it a couple times so we get a bigger font here.
Perhaps. Well, that's a little bigger, a little better. There we go. Whoa, cool. All right, so yeah, just do a quick search on Tenable. Hopefully you guys are following along in your AWS instance. And two images will come up. You'll see the pre-auth scanner and the BYOL scanner. And you may be asking yourself, why two scanners? Why two instances? So let me take a second just to explain the differences, and then we'll show it in the interface so you get a real feel for it. But the idea is that, long ago, this was several years ago, there was the restriction that folks couldn't scan their stuff. AWS has since removed that restriction, but the pre-auth scanner kind of bypassed that need. So folks didn't have to go through the credentialing process to scan their EC2 infrastructure or anything like that. We took on that burden for our customers, make it a little bit easier for them. And then likewise, the BYOL instance, that's there if it's like, I have my own license, I have my own key, I just want to spin up a scanner and do it at any time.
Hey, Tim.
Yeah, go ahead.
Just to jump in, if folks on the line today in our Howdy partner episode, if they want to get their hands on experience with this, how would they get started?
Yeah, so there's a couple different ways. So obviously you can download a pre-auth scanner here if you want. Okay. It will ask you for what is called a linking key. That linking key is actually found in the IO interface. So if we come back here, Tenable.io, you can see I have several linked scanners, a BYOL and a pre-auth. So if I were to go through this process and go through the setup, eventually it's going to take me to go through a whole EC2 instance setup. Give it an access role, pre-auth role. In this case, I would add an IAM role. In this case, I just set up the scanner. But if you want to get your hands on it, you do need to do a trial license at Tenable.io. That's probably the easiest way to get up and running. And it's super simple. Just go to tenable.com/try, select Tenable.io, and boom, you'll be some type of service rep will be with you probably within 24 hours and say, hey, do you want to give it a try? Here you go. Here's a download. Have at it. Register register a license, and you can get onto Tenable.com. And then from there, that's where you come into AWS. If you have EC2 instances or AWS infrastructure you want to scan, you would use one of these guys. So just to show you what that looks like, I'm going to pop into it. If I just say continue to subscribe, it's super simple. And then in continue with configuration, it's literally going to say, go ahead and pop you into, kind of the flow of launching the software. So you have a license agreement, all that good stuff. And then you can actually go ahead and create it. So I'm not going to do that now because I've actually got one already kind of spun up. But basically through that process, what it's going to do is it's going to say, hey, how do you want to manage this scanner? It's kind of a standalone instance right now. And in that case, you would say, I want to manage it by Tenable.io. You give it a linking key, link it up, and boom, you're ready to go. So what does that mean, right? What do we use this for? So to give you guys some context, I'll just kind of bring up my AWS instance. We'll duplicate a tab here. And I'll show you what it looks like in my console. So go to my EC2 instances. So in this case, I have several running instances in my environment. And then right here I have my AWS BYOL scanner. You can see it's up and it's running. So I can actually access this particular scanner on this IP on port 8834, and I could log into that scanner if I wanted to. So likewise, it also has access to all of these running instances in this particular VPC. And you may have multiple VPCs. Most large-scale organizations do. You can actually peer those VPCs if you so choose and have a single scanner. Or in our enterprise customers, you can drop a scanner in multiple VPCs. So just think of it as an engine that's sitting alongside your infrastructure. And now you have the ability, because it's linked up to Tenable.io, to scan that infrastructure. I'll pause there. Rob, Jeong, or Will, is anything you guys want to add? Any questions there?
Yeah, question there would be, based on the scanning that you perform, what sort of metadata is presented in the console?
That's a great question, yeah. So once you've kind of stood up your scanner, and you'll notice there's BYOL or pre-auth, let's head over to scans, right? That's our next step. That's where we're going to say, okay, I have a link scanner. It's talking to Tenable. It's sitting in that VPC maybe. Now it's a matter of just creating a scan, and it's literally this simple. There's tons of pre-tuned scan templates that come out of the box for our customers. It takes a lot of the legwork out of the equation. We've pre-tuned them in line with Tenable best practices. But know that you have kind of the advanced scan template. That's your Swiss Army knife. You can use it anytime to accomplish just that. And if I come here, let's say I have an AWS scan. I can scan by tags or by target groups. So you might tag your infrastructure. We'll talk about that momentarily. But if I select, for example, a pre-auth scanner, you'll notice I have the ability to select targets. So with a pre-auth scanner, we're using an embedded IAM role when we do that scanner setup, and it gives us the flexibility to immediately just pull and suck targets in. So this is really good if you're not using something like tags, or maybe you're not using something like private IP space. If you just have instance IDs, it gives you the flexibility to select those from the interface. Likewise, if I come back at that basic network scan, in this case, I just use my BYOL scanner, you'll notice it's saying use tags or targets. So if you haven't, if you're not familiar with the concept of tags, we make it super simple. Come show you guys real fast. Basically, inside of Tenable.io, you can tag anything that's pulled in from AWS. So we have what we call a connector. I'll go ahead and select that guy. Oh, go back. Go back to new interface. So the connector pulls in assets on a regular cadence. And really what it is it's using CloudTrail functionality to pull in any net new asset. So like an EC2 instance that's running, maybe it's stopped, whatever it may be. And all this is default functionality. So it's built into the interface. So I'm just selecting, you can do either keyed or keyless setup. Why this is important is for that BYOL scanner, as you guys saw, we don't have targets, right? So we can just pull in and suck in targets on a regular cadence. This is super important for folks that maybe have an ephemeral asset list. So maybe short-lived assets that are spun up for certain workloads in EC2 instances. Our security teams need to be able to see those. They need to be able to assess them, especially if they persist, or maybe firewall rules weren't appropriately provisioned. So this gives you the flexibility to do that without even actually kicking off a scan. So just come in, name the connector. In this case, it'll be your account ID for your AWS instance. And then that would allow you to create a stack. It's an automated workflow to pull in and suck in assets. And we can do so by tags. So then, again, you'll see once those tags are there, you can scan anytime. So Rob, I was kind of giving you a little bit of a peek underneath the hood, but you asked specifically about like, well, what does the data look like? Once you've executed a scan, what does that look like, right? So that's a great question. So that's where we're going to go next. So let's say we've created a scan, we've executed that scan. Now we want to look into some of that vuln data. So if I come here to my vulnerabilities, so we always encourage our customers to do fully authenticated scans if you can, if you have that flexibility. So if you're scanning an EC2 instance with an AMI image, you know, it might be something as simple as adding creds to that scan. We'll talk here momentarily about agents, and how you can use agents to scan the data as well. But this is scan output, this is vuln output. Again, if it was like a Microsoft SQL Server, we're going to assess that host for any known vulnerabilities based upon its operating system, firmware, all that good stuff. And basically we'll footprint it. We'll say, what does the host look like? What is the description of a vuln? What's the solution? How do you fix it? Maybe it's a firmware update, maybe it's a KB that needs to be applied, or registry keys that need to be updated. And then we'll show you all those particular hosts or IPs that have that vulnerability. And then on the left side, you'll see some additional telemetry data. These are things around like what we call VPR, or vulnerability priority rating. So every CVE out there has a vulnerability rating. It's provided a CVSS score. Those scores, though, are static in nature, and they never really change. So with Tenable, we provide you a dynamic score that's based upon threat intel feeds, so threat-backed intel, and it follows that bell curve of a vulnerability. Most vulnerabilities, when they first come out, like a 0-day, they're not widely used yet. So, you know, the probability or likelihood of you actually being exploited on it might be relatively low. That's why we talk about exploitability a lot at Tenable, because maybe 180 days or 200 days out, there's a mature exploit. Maybe it's part of a major framework like Core Impact or Metasploitable. So that takes that ability to exploit that vulnerability from like, hey, you need a PhD, down to like, yeah, it's somebody in their basement like myself that could probably do it, right?
Like kitties as well, right?
You got it, man. You got it, right?
Yeah.
So think about that as a large-scale organization, right? You know, if I have something like a vulnerability priority rating that's telling me, hey, this is an external-facing host. Anybody can hit it. Anybody can scan it. They could use a Nessus scanner to hit it. And oh, by the way, you know, there's a critical and exploitable, and there's an exploit that's available as part of a major framework. Well, you know, logic would dictate that we should probably address that first, right? We should get on that one versus maybe one that has a low-hanging fruit, high severity or complexity in terms of exploitability, right? It just helps you make a decision as an organization as to what to tackle first. All right, any questions on any of that stuff?
Maybe if we can zoom in a couple times again.
Yeah, totally. Probably a little small. What I'm going to do is try to zoom in over here, because this is super important. And what you guys will be noticing here is just your exploitability and the VPR score. If I scroll down, you'll see some of the key drivers. If you're like, why is Tenable calling this a 9.0? What does that even mean, right? Well, we talk about the threat intensity, the exploit code maturity, how long it's been out there. And then 2, we'll provide threat sources. So this is validated threat intel. We have our own proprietary threat intel feeds, and we also have some that we pay for. And then we map that to CVEs and give it back to our customer. So I always tell a story that I used to do this stuff manually because I was an Uber geek when I used to support organizations. And it was a pain in the butt, right? Nobody likes to do this. Security professionals, you know, we need to go have beers with our friends at the bar too. So that's kind of what this is going to give you some time to do, right? Frees up some time so you can go have a beer with your friends, and really just focus in on what matters, right? So we're not just chasing ghosts. We're not going around trying to, you know, play whack-a-mole and remediate every vulnerability underneath the sun. So any
from an
questions on
actions
that?
from an actions perspective, what options do you have available to take on these individual findings?
Totally. Yeah, that's a great question. Let me go back here real fast. So for any of these, you can do a couple different things, right? I can immediately launch a remediation scan directly from the platform. So this is important. So a lot of folks might be given access to the platform as an application owner or an infrastructure owner, and they say, hey, this is your infrastructure, you own it. That also means you own the security around that. So if I'm given kind of access to the platform, what I can do is kind of work my list. So I can look at vulnerabilities from that vulnerability detail list, and I can start to launch remediation scans against them. I can also use things like different filters in here. So I really kind of bring the power of VPR to life. So I'll show that to you real fast. In this case, we're looking at medium CVSS scores with a high VPR. So a lot of organizations say, I'm just going to hit my criticals and my highs first. I'm going to work that list. And that's great. But you know that if you're just using CVSS scoring, in this case, you can see it's a Microsoft vulnerability. It gave it a low CVSS score. But again, we follow that life cycle of the vuln. We can see it's now part of major frameworks like Canvas, Core Impact, Metasploitable. It has a high VPR score. So in this case, if I'm working my list, I can launch a remediation scan directly against this host. Once I've done that good patch work, in addition to that, maybe I say, hey, look, this is a vulnerability, but I don't believe it's a medium based upon our internal organization's risk threshold. Instead, I'm going to calibrate or recast that risk. So I can change that risk threshold from a medium to a critical. Likewise, I can also accept it. So why would you ever accept a risk? Think about a server refresh effort or whatever it may be, right? Maybe some vMotion or maybe some AWS motion that you guys are maybe migrating things. You might decommission old servers, old infrastructure, and push up and down. So again, just gives you a lot of flexibility in how you manage your risk and how you compartmentalize that risk as well.
I have some follow-up questions there, I guess.
Yeah.
One, so the thing that you just showed us, the recasting, kind of accepting the rules against what's recommended, is that essentially, are you essentially able to customize some of that
Totally,
as a base background rule or like a basis rule, I guess? I don't know what it'd be called, but
so you can recast, and with that, you can calibrate your risk, so to speak. So again, like if this is a vulnerability on a host, that the host has multiple compensating controls, buried by firewalls, has logging and monitoring in place, like an IDS, IPS. Then you're like, yeah, it's a risk, but maybe it's not our top priority right now. And I don't need to see this every time I want to scan. That's really where recast comes into play. And then likewise, you might have an infrastructure team that says, you know what, right now we're not going to address this vulnerability because we have deeper burning issues that we need to get to. That's okay. You can accept it. And then for any of these, you can create dashboards off of those to say, like, look, while we're accepting it, we're not forgetting about it. We're going to set some target dates against those. And if the vulnerability goes past that target date, or maybe that server refresh effort goes past that target date, that vulnerability is going to pop back up and we're going to see it.
And I guess my other question was, are there, I didn't see it on the screen, but I'm assuming there's some alerting things that you can do to broadcast to your teams and stuff like that in case there's high priority vulnerabilities.
Yeah, so everything that you see from the interface, and we'll get into this more as we go through the demo, and we go kind of play around a little bit, but everything that you see from a UI perspective can also be done from an API perspective. So one of the links that we'll drop in the chat is the developer.tenable.com page. So we have default integrations right out of the box with major SIM solutions like your Splunks, your QRadars, even some SOAR solutions like Demisto as well. So when you talk about alerting, most security professionals that are looking at this stuff are probably looking through the lens of a SIM. And that's really where they want to see it, as a single dashboard. So we integrate right out of the box with all the major kind of SIM players. And then if maybe you're using some of like a homegrown solution, even have customers that use like open source solutions as well, you can pull in any API data here as well. So a very friendly API and Will kind of demonstrate some of the things that he's done with it here momentarily. But know that even if you are not like heavy coder, and a lot of the folks on the call today are developers on the Twitch channel, but some folks aren't, right? All it takes is accessing secret keys inside the platform, and then you can start, it'll generate the Python, PowerShell, Ruby script, whatever. So you can pull vuln data out, create your own custom alerts, really on the stuff that you care about, right? Cool. All right, so that's the first example, right? We talked about the AMI image and how to scan with an AMI image. The second example I'm going to pull up now is scanning with an agent. So that was kind of the first example, right? So think about, and again, if I come back to my infrastructure diagram, we had a Nessus scanner here. One Nessus scanner that we dropped in that VPC, and we could scan multiple hosts. It was sitting alongside those running EC2 instances like I showed. The next example is a Nessus agent, which you can deploy to an EC2 instance, but we can also deploy to remote workforce or workstations as well. So some benefits and considerations, I'll blow this up a little bit. Why would you use this versus maybe an AMI image? So it can be deployed using native AWS technology. So the systems manager or the distributor, we can pre-package software deployments, push them out on a regular scheduled cadence to our EC2 hosts that are running. It allows for fully authenticated scan without the need for credentials. So that's huge, right? A lot of folks don't want to worry about doing they want to do an authenticated scan, but they don't want to worry about the need for creds, right? It's cumbersome, it's a pain. So since this is pre-authorized software on that EC2 host, it can see it, it can scan it. It does similar to like basically a fully authenticated scan of a Nessus scanner, but it's dedicated to the host. And it's one-to-one, whereas a Nessus scanner is one scanner, many, or one AMI image, many EC2 instances that I can scan. In this case, it's one scanner to one EC2 instance, one mini scanner almost. We've also had customers bake this into their golden AMI image. So if you're thinking about your IT stack right now, maybe it's very distributed, right? Maybe it's not centrally managed through IT. Maybe you have multiple VPCs that the business they spin up as quote unquote shadow IT, or it's not centrally managed through IT itself. So to get a chokehold on that, a lot of organizations will either schedule the push of an agent, or they'll just bake it into an image and say, look, you can only pull from this marketplace image that already has the Nessus agent built into it. And then finally, we can use things like Lambda functions to alert when a host doesn't have an agent. So maybe you're already coming to it after the fact, you push out your agents. You can also use native Lambda functions inside of AWS to say, look, this doesn't have it on there, do that delta check, and if it doesn't, alert me so we can push it. So let's jump into what that would look like. So I'm going to go back to my sensors real fast. So these are all my cloud-hosted scanners. We talked about our link scanners, our pre-auth, and our BYOL. Over here on the left, though, you'll see agents. I have a Windows agent as well as a Linux agent. These are both in my AWS group. So these are like mini scanners, basically dedicated to those EC2 instances. To actually bring that to life for you guys, what would that look like? So inside, I'm going to pop into AWS, kind of give you a peek underneath the hood. In this case, we have multiple buckets. I've just created a couple S3 buckets. I have one for a RHEL agent, Nessus agent bucket, and TO test agent. So literally, you can do the same. Just come in here, call it AWS test bucket. I leave everything default. You can add tags if you want.
I'd be surprised if that bucket wasn't taken.
What do we call it? This is where I'm bad with naming nomenclature. Well,
you can do Howdy partner, Tenable, 1, 2, 3, 4, 5, 6. Add as many numbers as you can to avoid.
I love it. That's where it gets some really creative names, right? So from there, I would just create the bucket, and inside of that bucket, all I'm gonna do, there's my Howdy partner 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All I'm gonna do is upload a file, and what is that file? It's the agent. So I'm gonna come here, hit add files, call Nessus agent for MSI for Windows host, and just upload. So now I can call this, right? It's uploading right now. I can call that agent at any time, and I can use it as part of regularly scheduled deployments for my infrastructure. So it doesn't matter if my infrastructure is changing, it's very dynamic. That's okay. I can schedule regular pushes of these. So if it's matching that OS or that infrastructure, I can push it out. And most folks have a standard build. That's what we've come across. They're either, all in on Amazon AMI images, or all in on a Windows images, or CentOS, or Ubuntu, whatever it may be, doesn't matter. So I'll go ahead and close that. If you're wondering, where the heck did Tim get that agent file, just head out here to tenable.com/downloads. You too can download an agent file. Basically, you'll have multiple, right? So we have, whatever it may be, we have an agent flavor for it, be it Debian, Amazon, Red Hat, Linux, you name it, right? So that's essentially what I pulled in here. So I have an S3 bucket with an agent in it. Cool. What do I do now, right? Next, as you guys can see, we're in the Systems Manager console. So we can use the Systems Manager, again, native AWS functionality, to push out our agents to anything that's running on the EC2 instance. So there's many that are owned by Amazon. If I select owned by me, I have a couple here that I've already kind of pre-created, one for Windows, one for Red Hat install. But literally just come here and create the package. We'll call this Howdy package. And then in this case, I think I had a Windows MSI file. Again, you can either add the software or choose that S3 buckets. So if you didn't want to use the S3 bucket, you just pull it in here, or you can enter the S3 bucket name and pull it from there. And then in this case, I'm pulling in Windows. And then it's going to ask, what about install scripts, right? So if you go out to Tenable.com, you'll find several different scripts. And I'm actually going to use one. They're already out there. But basically, we're just using an MSI exec install command in this case. So I'll break this down a little bit. So MSI exec-I, so it's going to be silent install. Pull in my Nessus agent. Link it up to cloud.tenable.com on 443. How are we linking? Well, this wonderful alphanumeric linking key. Do a quiet install. And then you can also add update scripts if you so choose. And that's it. We'll just create the package. Oh, didn't like that. Need to add in my Howdy partner bucket and agent MSI. Cool. There you go. So once that runs, that's basically going to push that agent to any host that meets that criteria. And in that command that we were talking about, it's going to install it and then link it to Tenable.io. So literally, it'll immediately pop up in this interface, and that's what this is, essentially. It's installed on our local running EC2 instance in the cloud. This is a Windows AMI. I'll come out here, here's my Windows agent. It's running. Since it's running, I push that instance with my S3 on a regular cadence, and booyah, there it is. So that's great. Now we have an agent on an EC2 instance, but now what, right? Now we just group those via agent groups. So I can group all my AWS folks into one group, all those little mini scanners in one group. And then from there, I just run a scan, just like any other scan. So in this case, I'm going to create a scan, use my agent scan, do a basic network scan, and then it says groups. Which one do you want to choose? There it is, our AWS group. And you'll notice no credentials. Why? Because it's all pre-authorized software. So it can do a fully credentialed scan. The bone data looks exactly the same, but it's just how we deploy it to the endpoint, right? So this is a very creative solution for folks that may be using very dynamic infrastructure. This gives you the flexibility to get into that and see those hosts.
So you have authenticated and unauthenticated capabilities, but specifically with this, you're speaking of a golden AMI, right? What exactly is a golden AMI?
Yeah, so in this case, we're just using native S3 services as well as like Systems Manager to create a bucket, an S3 bucket that holds that agent, right? That MSI file in this case, and then push it out to different hosts. But what a lot of folks will do is they'll actually embed this agent into an image that's available in their private marketplace. So, again, we talked a little bit about shadow IT or different organizations that maybe have a decentralized IT. It's not centrally managed. That comes up a lot, especially with like, different higher ed education. That comes up a lot. They're all kind of funded differently. So we could have a private kind of marketplace essentially, and we could bake that image into it, and they could only select a pre-authorized image that has our agent embedded in it. So that gives security teams, essentially, instead of having to do what I showed you, right, which is after the fact to deploy an agent, they know from day one it's in there. And what will happen is, as soon as they select that, it would be available. It would pop up in their sensors. They would see it as yet another agent in this group. And as you guys saw in that script file, we can also use grouping commands. So basically, anytime a new agent's come up, I can group it into my AWS host. So if somebody pulls out, a golden image from the marketplace, guess what? I'm going to see it's going to show up right here. And then likewise, I just have scheduled scans that run on a daily basis. So I have complete asset coverage, continuous asset coverage, and continuous visibility into my network.
Excellent.
Yeah, cool stuff.
Sounds
All right.
great.
Yeah,
Just want to interrupt you a little bit there.
totally.
Just to say, if you are just joining the show, we are AWS Howdy partner, where we highlight awesome, cool things that our partners here at AWS are doing. With us, we have Tenable, Tim and Will from Tenable, talking about infrastructure security on AWS. And Tim just went over two types of scanners on AMI and agent scanner. So now he's going to talk to us about frictionless.
Cool. Yeah, but wait, there's more, right? So the one thing that we're really excited about at Tenable is frictionless to scan AWS infrastructure. So you may be asking yourself, well, Tim, what is frictionless? Tell me more, right? So frictionless introduces the concept of basically infrastructureless ways of scanning. And it is completely proprietary to Tenable. It's unique to Tenable. And it's really exciting because it gets out of the game of using an AMI image. It gets out of the game of deploying agents. If you talk to any security practitioner, they may tell you that, like, yeah, well, it's great. It can become a lot of work, right, to manage. And I want to focus on vulnerability remediation, not necessarily the infrastructure. And we recognize that, and we worked with AWS and our partners to develop a way in which to meet that need. So basically, frictionless just uses that connector that we were talking about earlier. It connects into your AWS environment, enable things like cloud trails, AMI roles, different access groups. And if you enable frictionless, you can pull in tagged assets across your EC2 running EC2 instances and say, yeah, for this asset, assess it using frictionless. So what is that actually doing? How is it actually scanning that? So what it actually does is it just pulls off of the SSM agent that's embedded in an EC2 instance. So for folks that may be new to the AWS infrastructure, many of the images, and not all of them, but many of them have an embedded SSM agent. And you can use things like Systems Manager to manage those agents, manage those endpoints. So you can deploy it on a host, or many by default already have it pulled in. I think many of which, I'm trying to think here. Hey, I know Amazon AMI image has it. Linux, Amazon Linux 2, Mac OS X, Ubuntu, Windows Server 2008 through 2016, and 2016 through 2019. So the major players in the space already have it embedded in, and then likewise you can push it out. And what we're doing essentially underneath the hood is, instead of us deploying an agent against that host to scan it, we're just saying, hey, give us your data, give us your metadata, and we'll assess that for firmware, operating system, all that good stuff, and find vulnerabilities off of that. So it actually eliminates completely the need for any type of infrastructure on the host. So as you can see, we're moving infrastructureless, right? So if I come here, go back to create a cloud connector, do the key list setup, just name it, add your AWS account ID. It'll ask you then to create a stack. That's where you're pulling in those roles, those groups, those users. You're creating a Cloud Trails enabled connection into that environment to do regular asset pull. And then here you'll see I can start to tag those hosts and pull them in and assess them by tag. So it looks completely different. We've talked about scan setup. We went into our scans. We created or scheduled a scan. In this case, we're going to go to our assets view, because there is no scan. It's just doing it automatically, which is amazing. So from there, you can see where's the source coming from. This is my Ubuntu instance as well as an Amazon EC2 instance. And I can see this little earmark, first seen, last seen, because I enabled it with that frictionless assessment. So you can see the SSM agent on there. So we'll click into this guy, and then we can see when it was first and last seen, and then the vulnerabilities that were assessed off of that host. So Amazon Linux is actually notoriously up to date, which is tremendous. It's awesome. We love that. So there's not a ton of vulnerabilities, actually. But what you can see here is we can dive into any of them, just like regular vuln data. But again, all this was done through the magic of an SSM agent that is inherent on that host. So in this case, looks like got some older versions running on it. Might have some kernel flaws. Not a big thing. If you're like, well, hey, that's great. How do I fix it? Guess what? Tenable provides you with the solutions right here. So in this case, it's a Yum update for the kernel package on 18 of those hosts. They have a VPR of 9.6 and a CVSS rating of 7.8. You too can remediate those vulnerabilities with a few keystrokes. So hopefully you guys get the idea, right? With the SSM agent, really the power or kind of the advantage is that there's no infrastructure. It's literally just taking a connection into that environment. It's using the embedded SSM agent. And then we're just passively on a regular cadence, footprinting that host, doing an S3 dump of the data, and then footprinting the vulns off of it. So it makes for some very, very simplified scanning. And this is a great use case if you have very ephemeral assets.
Question here. Is there, I mean, this seems great. This obviously makes my job a little easier. But,
that's what it's all about, man.
Yeah.
Making the job easier.
But would there be a case for somebody to use agents or AMIs instead of frictionless? I mean, I feel like there might be some use cases or anti-patterns there against.
Yeah, totally. So as I made mention, there are, we came out with frictionless, I think it was like fourth quarter last year. So relatively speaking, it is relatively new technology. It works really well with AMI images, like Linux-based images, anything that has an embedded SSM agent by default. That being said, those agents or those images, I should say, are updated pretty regularly. So it's really more purpose-built, I would say, or better used for dynamic workloads. Maybe that host is being spun up very quickly. We don't have time to push out an agent to it. It's not going to persist. Maybe it's a week or less. We just need to get a quick and dirty assessment of what does that host look like, right? And what risk does it present? And is it on the most recent firmware update? Does it have any kernel flaws? Especially if it's using things, supporting infrastructure that is very dynamic or scalable, like things like maybe using like EC2 services or I don't know, different like containers, maybe supporting container workloads as well. Whereas an agent or an AMI image is really more purpose-built for persisted AWS infrastructure. It's going to be there for a while. We know it's going to live there for a long time because it has a very specific purpose, maybe a web server, whatever it may be. And we want to assess that for regular vulnerabilities. So I actually encourage folks to use multiple different solutions. Just it really depends on your infrastructure, what that looks like, and then how dynamic your workloads are.
A question that might arise here would be, in terms of your customers tagging strategy, is there a way to scan multiple tags? Like if you have prod and okay.
Yeah, so we actually encourage that. Tags are great because we know, again, we have very dynamic infrastructure, very dynamic workloads inside of AWS. So I can tag an asset as I saw it from the connector, right? It was seen by the connector, tag as such. But then maybe also tag it by operating system, maybe tag it by VPC instance, whatever it may be. So you may have layered filters or layered tags, and that's okay. We actually encourage that because it helps you get very granular in what you want to scan. So think about it, instead of scanning my entire instance, all my running instances in AWS, I could say just apply this certain criteria and only scan these instances. That way I'm getting scan data back faster. I can assess those hosts and get that information to line for the folks that are actually remediating it.
Excellent.
Cool. All right, guys. Well, I sincerely appreciate everyone's thoughtful questions and their engagement. Hopefully you got a kick out of me and got a kick out of my presentation. Now is the exciting stuff. Now is the really fun stuff. Will's actually going to take over the lead, and he's going to kind of walk us through what it looks like if you were to integrate something like web app scanning inside of your DevOps pipeline. So without further ado, it's all yours, Will.
And I was just going to ask how developers can integrate with the CI/CD pipeline. So excellent.
Perfect. All right, can you guys see my screen?
Yep.
All right, perfect. All right, so I'm going to kind of tag along based off what Tim said to some extent, but we're also going to change direction a little bit. And instead of talking about securing infrastructure itself, so instead of saying, hey, what are the vulnerabilities on that Linux machine over there, we're going to be talking about things such as securing the SDLC, looking at the application side vulnerabilities. Specifically, we're going to be talking about this guy called DAST, Dynamic Application Security Testing Tools. And just a real quick kind of agenda for how this next 45, 30 minutes, depends on interaction, is going to go. So I'm just going to do a quick context, like make sure that everybody knows what DAST is. And based off that context, we're going to talk about how we can insert this test into the SDLC and help create a secure SDLC. And a lot of you guys probably have some good ideas around what a secure SDLC looks like. But I would say DAST is one of the things that has a tough time getting into the SDLC. And that's because the problem a lot of times looks like a square peg round hole kind of a situation. So we're going to give you our recommendations. I'm going to tell you how we do it here at Tenable. So the guys that are back in that are developers for the actual Tenable products themselves. So what that SDLC looks like. And I'm not going to talk too much about static code analysis or anything like that. Just going to focus on this DAST portion. But if anybody has any questions, feel free to drop them into the chat, as well as Rob, Jeong, Tim. Feel free to interrupt me at any time. Hopefully, my enthusiasm is contagious, but hopefully I don't get too enthusiastic and talk. But I can if you guys let me. So feel free to interrupt. All right. Okay, so we've got a lot of products here. Tim just talked a lot about the Nessus scanner, Nessus agents, all that kind of great stuff. We got integrations out to Wazoo, all that great stuff. We're going to talk about this guy right here, web application scanning. And I want to start off by kind of introducing what DAST is, so that you can get an idea for what kind of vulnerabilities this guy is going to find. And I think that that's going to help you guys kind of put into context where this belongs in the SDLC. So, hey, am I trying to scan code? Am I scanning or running it? Well, what am I doing with this guy? So why DAST? And DAST, Dynamic Application Security Testing or tool, depending on which T you go by. So Tenable WAS, Web Application Scanning, is a DAST scanner. There's a lot of DAST scanners out there in the market. If you guys are familiar with OWASP, their OWASP ZAP is a proxy that also has a DAST component to it. So if you're familiar with ZAP or Burp or something like that, they are proxies that happen to also have DAST components. So why is DAST awesome? So DAST is awesome because it's perfect for the enterprise security. So thinking from scale, and then we'll talk about injecting it into the SDLC in a second. But let's just talk about the scale for a second, getting it enterprise-wide. And again, this is meant to be vendor neutral. This is not just us, but like DAST in general. So DAST, it scans, kind of like that Tenable Nessus scanner scans, and it scans a Linux host, except a DAST scanner is going to, you can think of it as opening up your web application in a browser and then scanning, what it sees in the browser. So we actually use headless Chrome under the hood. So if you can render it in Chrome, you can scan it with our application scanner. So why does that sound awesome? Well, we don't care what language what language your application is written in for the most part. So, regardless of whatever the back end is, whatever the front end is, so long as we can render it in Chrome, we're good to go. Or, if it's an API or something like that, so long as we can send requests and get responses from it, again, we're pretty much good to go. As well, because of the fact that, we're scanning it, while it's in the browser kind of a deal, we're going to be able to kind of spot the issues while the app is running. That's awesome. You get lower false positives as well. You get the hacker view. And I put, lower false positives in quotes because it really depends on the application and what are you comparing it to, all that kind of thing. But I've seen plenty of static analysis tools which go ping, 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 ping every time you run them. it turns out that it's 90% false positives because it's mitigated by, a part of the app that's upstream that hasn't been put in yet. That's always fun. So second part, why, again, is DAST awesome from an enterprise perspective? It scans the browser, right? You're opening it in the browser. So you can scan it while it's in a testing state. You can scan it in QA. You can scan it in pre-prod. You can scan it in prod. And each one of those may have different sets of vulnerabilities as you're adding in additional pieces to the pie, right? So if you think about it, does your QA app mirror exactly what is in production or what is in pre-production? The answer is no a lot of the times. So you can get a really good idea of what each one looks like along the way and where vulnerabilities might get mitigated upstream and things like that. And the second part is that it's kind of independent of the SDLC and the various pipelines. And in my example today, I'm going to be using AWS's code pipeline just to show you guys what that looks like. But honestly, whatever it is, you make an API call out to us, and then we'll scan it, if you're putting it into the SDLC. But if you're outside of the SDLC and you're just scanning things in production, which that always goes down super well, always scan in production. I'm going to pause for a second now, sarcasm. So if you're going to scan in production, always be aware of that. Hey, this could have an adverse effect. Let me tone this way down before I actually launch the scan. But this is another great tool for the security team, not necessarily for the developers, but the security team, because I don't need access to your pipeline. I can go scan it in production. And again, why do I need that? Well, a lot of times the security team and the developers, not necessarily button heads, but yeah, a lot of times they are button heads. But maybe they are kind of siloed off, and the security team says, "Hey, I'd like to work this into the SDLC," and the developers say how, and then the security team says, "I don't know," and then it kind of stops there. I've seen that conversation play out quite a bit.
Will, you're like the most interesting man in the world, where you don't always scan, but when you do, it's in production.
I don't always scan, but when I do it, it's in production.
It's in production.
Living life on the edge.
Yeah, we may have to make that into a commercial one of these days.
I like it. Yeah. Wait, sorry, who gets the trademark on that? Is that Tenable or AWS?
Definitely not.
I mean, Tim mentioned it, so
yeah,
we'll
let
him
him
out
later.
first.
That's okay. So the last reason why it's great for the security team, versus just the devs, is because it's DAST. Again, you're trying to scan a running application, by rendering it in a browser, sending requests, getting responses, playing with the DOM, all that document object model for those that aren't web app developers, and playing around and all that great stuff with the application. So that actually doesn't take the same skill set as a lot of the static code analysis tools. So a DAST scanner has kind of what I would say is the lowest barrier to entry in AppSec. Instead of needing to know a language, instead of needing to know any of that, right? I don't want to say it's point and shoot, because there is some configuration that's going to have to go into it, but it is more point and shoot, closer to like that Nessus scanner, how Tim was saying, okay, you press the scan, it brings back vulnerabilities. Yeah, you got to put in credentials, and sometimes things can go wrong, but really it's not going to be as many errors, and it's not as steep of a learning curve for non-developers as some of the other tools out there. Then the second part to the low complexity is the architecture. So it's very similar architecture to what Tim was just talking about. With you can use our cloud-based scanners, or you can use your own scanners. You can put them in. But instead of the Nessus way, where we've got the Nessus agents that go on the box itself, we go completely agentless, and we go with the network-based web application scanner. So let's say you've got 20 applications in a particular VPC, or maybe you've got them all up in your test environment. You can just put a single scanner in there and scan, one every few hours or so, scan them each once a week, however you want to get that done. And you don't have to put an agent on each individual application where it's slowing down the application and you can't run other tests against it and all that fun stuff. All right, so just because I kind of ended on the architecture there, I'm just going to talk about the architecture for a second here. And I mentioned we've got cloud-based scanners, and then we've got internal scanners as well. And I want to start off with talking a little bit about the cloud-based scanners. So the cloud scanners will auto-scale according to customer load. So let's say that you guys launch, 10 scans all at the same time. If that were to happen and Tenable doesn't have any additional scanners in our scanner pools, we will then auto scale up to meet customer demand. And that's good because we have some customers that have thousands of web apps that are, at any given time, they could start 100 new scans using those cloud-based scanners. So why would you want an internal scanner if our external scanners are, good to go and will auto scale according to your load? Well, if you have a good security practice in place, then there's a good chance that you guys are going to block anything that looks like a web app scanner from coming into your environment. So by using something like a WAF, for example, Amazon's got one. But so if you use something like a WAF, that's going to block scanner communication all day long. It's going to look at that and say, you're trying to do or 1 = 1? No way. And then it just blocks the IP address and says, no more from you. Okay. So in that case, what you would do is you would take our scanner, you would put it into your internal environment. And when I say internal, it could be cloud, it could be on-prem, whatever you want, or wherever your development's being done. So that's essentially what it's going to look like. And you can deploy as many of those internal scanners as you guys want to. As well, each individual scanner can scan up to 4 applications simultaneously to get those good results in, and all that kind of stuff. Okay, so what does this look like in the SDLC? And this is what I would say, a lot of folks, if you were to say, how do I get that into the SDLC? Well, based off what I just said, about what DAST is, we're scanning a running application. That means that instead of trying to scan, like a static code analysis tool might after you do the build, we actually need to wait until we deploy the application in order to scan it. So you might have something like this where, developers push to it, some sort of repository, and you've got code pipeline that says, okay, all right, I saw a change in Git. Okay, let's go ahead and build that once build's complete. Okay, great. So now that build's complete, we're going to go push this into QA after, we've deployed it into QA. We'll have maybe something like a Lambda function, which is going to make an API call back out. And if we go back out, you're not going to communicate directly with the scanner. You're going to make your API call up to our SaaS-based platform, Tenable.io, which then tells the scanner to go scan, whether it's cloud-based or internal. So you'll deal directly with our SaaS platform. Okay. Let's go. All right. So once that scan is complete on the QA environment, then you're going to be sitting there going, okay, does this pass muster? So your next call might be, okay, I'm polling for the results to complete. I want to make sure the scan completes, and then we're going to check out the results. And I'll go ahead and pause. I didn't include it on this diagram, but you could definitely and absolutely have those results, go off up here to Security Hub or something like that, some sort of a third-party tool, and you could put in some sort of a metric saying, hey, anything over X, block it in the pipeline. Don't let it push to prod. Create a ticket or something like that.
For manual intervention or human manual steps, basically.
Absolutely. Yeah, exactly. You could automate as much as you want or as little as you want, and we'll go through that. Yeah, go ahead.
Excellent. Just wanted to also chime in here and just basically understand, are you enabling developers to shift left? And by shifting left is, introducing testing much sooner in the SDLC.
That's what I'm trying to do here. Yeah. So I would say that, through, and keep this in the back of your mind, DAST does not do well in the SDLC. And we'll talk about why here in a minute. And so the problem that I call this, I'm not unique in calling it this, but, the square peg round hole type problem. So I need to jam this into there. I want to shift left as far as possible. But what's going to end up happening is that this scan doesn't really do well as a blocker in the SDLC. So I'll just, so shoot forward to the end. Instead of having it as a blocker in the SDLC, what you guys might want to do is have this run on a schedule, once a week or something like that in a test environment. So this is what I would say, based off everything that I've discussed up until now, this is what most people think of when they're thinking, okay, how do I get DAST into the SDLC? So I'm going to show you an example of what this kind of looks like, and then we're going to go through some configurations, some manual configurations. And I think that once we see the configurations in the user interface, as I walk through a sample application, you guys will see, okay, all right, that was a little bit of work to get the configuration done as well. These scans can take hours. And I don't know about you, but if I'm a developer and I'm going to push something into a test, I don't want that test to take hours.
Indeed.
Right. So I just gave away the rest of the talk, but I'll keep talking anyways. All right. So now what I'm going to do is I'm going to Alt-Tab out. I'm going to give you guys a little bit of a demo, what that kind of looks like. And then after, I kind of walk through what that'll look like in the pipeline. I'm going to show you guys how to configure in the UI a web application scan, and then I'm going to go back to a little bit about what Tim was talking about and really focus on our API. So I'm going to simplify it. I'm not going to have a second environment for production. I'm just going to have, you can call this QA, and then I'm not going to make a secondary call that's polling and waiting for the results, just because I want something that'll actually be able to be done on a live demo, and that would take potentially a very long time to run. All right. Okay, so for the demo, what I did was I just looked at what was already available from AWS. AWS has a create continuous delivery pipeline where it's a super basic application, and when I say super basic, I mean super basic. That's it right there. Yeah, so that's our super basic application. All right, so in any case, I'm stealing that. I'm forking it into Git, and then basically, as you saw back here, as soon as the Git push is made, it's gonna have this nice, Git repo update, and then all this other great stuff. So I'm gonna go ahead and just minimize. And can you guys see the entire desktop, not just?
Yep.
Okay, just making sure sometimes that doesn't work out so well.
Oh, and while you're making that transition, we have a question on the chat.
Yeah.
Is it possible to integrate the web application scanning with other apps like SonarQube or Custom API?
Got it. I see what you're saying. Yeah, so SonarQube, I would say that DAST and SAST, they kind of, exist in two different realms. And while they can kind of feed each other a little bit, I would say that that's kind of minimal. And that's because DAST, again, is really looking at the endpoints that a web application has. And there's not a lot of great ways to kind of go from the code that you're looking at and changes in the code, for example, and map that to endpoints themselves. So, let's say that I've got this super simple application right here. I could probably pretty easily tell, where it is in the code. And there we go. So this is all that it is right there. So I can tell anytime this is changed right there. Okay, so that's going to Tenable was here. Tenable was here. So I would probably be able to map that change to this right here. But for complex app, when I say complex, anything modern, that's going to be a pretty difficult task. I would say that all of those guys can be integrated into the pipeline that you have. So you may have SonarQube in the earlier stages of the pipeline. And if I go back here, so SonarQube's probably going to exist right about here. After you do the build, it'll exist right about there. And then after that, you pass SonarQube, then it gets pushed into QA. And then after it gets pushed into QA, then we're going to have a Lambda function to do the DAST scan. So that they are all a part of the secure SDLC, but they're probably not doing too much in terms of feeding each other. They may all then be pushed into or pulled into Security Hub from there, where you can see the data kind of married together. Did that answer the question?
Yep.
No problem. Okay, so basically, I'm just going to follow the instructions that we had, that we've got from.
Can you zoom in a little on your terminal?
Yeah. Thank you. That is a great point. All right, so basically, all I did was I just made a change to. Not that guy. is. Okay, so basically all I did was make a change right here from hello world to Tenable was here. And if you're going through this particular tutorial, again, it says 35 minutes, but if you guys know what you're doing, it's more like 15 minutes. Yeah, it's super, super simple. But if you're a security practitioner and you're watching this because you love Tenable, you love the Nessus scanner, you don't have a lot of experience with development, this is actually a really great way to kind of get your hands dirty, spend a few hours, just kind of walk through. Okay, so now how would I go from here to putting DAST into the pipeline, for example? So the example that we've got here, I'm just going to go git add this guy right here. And again, these commands are copy pasting from what is in the tutorial, just to keep it simple. And then I'm going to do a push. When we do this push right here, we're getting, okay, it's going and updating my Git. So if I go over to the code pipeline that I've got right here, this should turn blue. Yep, okay, it turned blue. Great, awesome. So as I said earlier, basically it's just going to do source. Okay, cool. Then it's going to do a build. Then it's going to do a deploy. And then it's going to do this DAST part right here. So this is probably going to take about 3 minutes to go through. And that provides me some time to kind of walk into what it is that Tenable DAST is doing. So I'm going to share this, here in a second. Let's see if I can. There we go. Okay, so let me blow that up for you. Is that big enough, or you think a little bit bigger? Looks good. Awesome. Thank you. All right, so I got not really too lazy, but kind of lazy here with so I'm going to import URL lib3 instead of requests because I want to keep it simple, make sure that you guys don't have to upload any fancy zips. If you're not familiar with Lambda, this would be a really good example of something to get your feet wet. And I'm just saying that just because I actually hadn't used Lambda before I went into this example here. I used a few of the other things out there, but not really this. So basically, all I did was, if you remember that developer portal that we had that Tim went into, this all came from there. URL headers and everything like that, and then what the actual API call is right here. That was all from those developer tools that Tim brought up earlier. So before I jump over there, I just want to make sure that we're in the right place here. Yep. Okay. So it's in deploy. Cool. So I'm going to go over to the developer tools real quick. And I can go ahead and do this. All right, so if I go down to the web application scanning, all right, so the web application scanning bit, it's going to allow me to do things such as launching scans. I can then use the API to pull for scans after the scans are completed and pull the results down. All of that can be done through the APIs. So if I wanted to launch a scan, for example, I would probably, oops, sorry, it's lagging just a little bit. All right, so let's say that I wanted to launch a scan. I would go into the scans endpoint and I would just launch a scan. You can see the very top one here is launch a scan. You can see that this is exactly what I had. Okay, so URL, headers, response, and we even give you a place to enter in the exact parameters that you guys want to use. So right now what I'm going to do is I'm going to make sure that the scan has launched or, yep, okay, so the scan actually already launched. I missed it, the aha moment for you guys. So you can see I go back into the UI, the scan has launched, I've got it right here. It's running, it's almost complete. I'll be able to pull those results down or look into them manually. I'm going to make it a manual check right now just to make it easy. Click in, okay, I've got some good results coming in, mainly looking at some header-based vulnerabilities here. And that's because this is actually a clipped scan. It's very small. That way we can make it go fast. So I'm looking at all these vulnerabilities, and I go back over to the pipeline, and I'm saying, okay, that looks good. Yep, looks good. Totally legitimate. Yeah. All right, so the pipeline is complete. You can imagine the next steps after this. Again, maybe it's we push the results into another third-party tool or something like that, or maybe we've created some tickets to then send back to the developer, or maybe we just allow it to push to production so that it's not blocking. But again, what is it that is making this the square peg into the round hole? And that's what I want to kind of jump into next. Before I do that, any obvious questions coming up from you guys?
No questions here.
Okay, awesome. So let's go ahead and jump into it. And what I'd like to do is just kind of go to a scan that I ran ahead of time on OWASP Juice Shop. And OWASP, can't say enough good things about that organization. Basically, it is, great organization. They not-for-profit type. They are all about application security. That is their thing. And they created this nice test application. If you guys want to go test your skills, as you guys are learning how to hack or something like that, as you learn more about vulnerabilities, as you start to put security into your secure SDLC, you can come to this application, and they do host it out. There is a version that's hosted out on Heroku. As you can see, people have been playing with it since I logged into here. So that's all people passing the tests. But so this is meant to be a modern framework, because a lot of the test apps out there that people had built are like 10 years old or something. There's no JavaScript on the front end, or it's very, very light. This is meant to be very single page app like. So it's more of a modern test for your skill set, as well as the other tools that you guys want to bring in house. So if you guys don't have a DAS tool and you guys want to start testing out various DAS tools, this is a good test application to do that on. If you guys can't build it into your own SDLC yet, and you guys don't want to test anything in production yet, they've got Docker images available. They've got pretty much everything else there. Okay, so again, this is a scan on the OWASP Juice Shop. I did it uncredentialed, just like in the Nessus world of things. We've got uncredentialed scans, we've got credentialed scans, we've got very limited scans or full scans. But this is a scan on OWASP Juice Shop without authentication. And I want you to check out the timestamps here. So this was an unauthenticated scan of a not super large application. It's not a tiny application, right? I did do a full scan on this guy as well. And Tenable was here. Yes, they were. So I did do a full scan on this as well, and the full scan took about 3 minutes. And you remember how simple that application was. And that scan took 3 minutes. So this scan took about 5 hours, a little bit north of 5 hours, actually. Does that sound like something that's going to work its way into the SDLC very well? And the answer is no. I'm seeing heads shake amongst the audience. I can't see the audience. I'm just seeing Jeong and Rob, by the way. So I'm seeing people shake their heads no. So how do we get this into the SDLC? And that's the question that I want to kind of answer now. And then there's kind of two ways to go about it. So if you have, let's say, is it possible to get, I'm going to go ahead and pause and answer this question real quick, and because it's a natural place to pause. Is it possible to get related CVE, CVS data from the scan results? And the answer there is yes, if the application vulnerability has a CVE. So not all, as opposed to the Nessus side of the vulnerabilities, where you generally have a CVE for just about everything, the web application scanning results a lot of times don't. So for example, let's say it's a SQL injection vulnerability. I'll just walk through what the vulnerabilities look like real quick. So this guy does have a CVSS base score associated with it. It does not have a CVE though, right? So it's got a CWE, which is common web enumeration, as opposed to the vulnerability enumeration. So it's, very similar, in terms of like what you're looking for, some sort of a standard, hey, I need to map this to something. A lot of these vulnerabilities will have some sort of a reference if it's not a CVE itself. So just like Tim was talking about earlier, you can pull all this information out via the API. And, so I've got a vulnerability. I want to go create a ticket in Jira or something like that. I can create a ticket with just the description, solution, CAlsos, and then any CWE or something like that. All right, so what does this vulnerability actually look like? So the vulnerability actually is going to have a request response key pair associated. And when I say key pair, I just mean a pairing associated with it. So we clicked into the identification. Here's just kind of like the high level. But if I am a developer and or a pen tester, red teamer for that matter, maybe I want to validate the existence of a vulnerability. I'm going to go in and I'm going to look at the actual request that was made, and then I'm going to look at the actual response that we got back. So this is kind of like the proof is in the pudding, so to speak, right? With the Nessus side of the house, it was, hey, I logged onto the Linux box. I saw this was version X. It needs to be version Y. You're out of date. This is a vulnerability. It's got some sort of some sort of vulnerability associated with it rather, and voila, you're good to go. With web app scanning, it's going to be a different structure. Instead of saying, hey, I see version X, you're vulnerable to something, we need to send a request over, and in that request, we're going to see or 1 = 1. Maybe that's injected into the cookie header. So for example, maybe we've got that in here. We didn't in this example, but I'm just picking an example. In this example, it was in the actual URL itself, you see, right there. So we're doing a get, and it is on this URL. So let's just say, for example, is on the cookie, because that's usually pretty easy to get. So you're going to see that in the request. And then if there is a response and the application acted funky in the response, then we're going to say, yep, that's a vulnerability. So here's the proof rather than something's version X or version Y. All right. So how do we get this into the SDLC? Great source of vulnerabilities. It's a different type of vulnerability rather than looking at the SAS type. You may find others, they complement each other very well. But let's say that I do want to get this into the SDLC. As you said earlier, shift left. I work for a vendor, and I'm sure at some point in time we had, a lot of publications that all said shift left, how to shift left, and yeah, great, awesome. So how do you do that with DAST? It was almost kind of like, I don't think I've really seen too many articles say shift left with DAST, or if they do, I see them do this, right, or that they do this without really understanding what DAST is. And so hopefully by the end of this, you guys will understand what it is that DAST is and why it is that square peg. And then you guys will be able to work this into your SDLC as good as you guys can. So what are we going to do to make this more SDLC friendly? So if we look at the actual web application, that OWASP juice shop, we're just going to take a quick peek, and we're going to ask ourselves, what is this web application made up of? So I see a lot of things right here. If I click this, does it actually bring me to a new web page? No, we're just dealing with the DOM here. It's like, okay, so I click a button, there's an event, something going on in the background, and it says, all right, we're going to pop this up. Great. Are there any other web pages? Is it anything like that? And what I'm looking for is I'm looking for content that I can ignore because it's duplicated across the application. So let's say, for example, that I've been tasked with doing vulnerability scans and application assessment of a blog site, for example. Let's say that I am Reddit's engineer and I need to scan reddit.com. Are we going to scan every single page in reddit.com? Heck no. No. Yeah, that's way too big, and a lot of it is just duplicate content over the course. So instead of giving it and throwing the kitchen sink at it and saying, hey, we're going to give it the full scan, everything, what we can do instead is we can look at opportunities to start to optimize this scan. So if I go into the scope section, I can maybe find some URLs, some URL patterns using regex to say, hey, don't go scan that URL. It's duplicate content of stuff that you've already scanned. Or maybe I want to only scan very specific URLs. So I can change this radio dial from crawl all detected URLs to limit crawling to just specified URLs. So maybe you include only the ones that you know that you changed, something like that. And then as well, you can also go down to this assessment portion, and we've got this guy called DOM exclusion. So basically, this is going to help slow down the scan a little bit, but at the same time, this is also super important for sites that may have a sensitive piece to them. Maybe your QA version of the application, if you guys were to interact with a button, such as create new user, maybe it actually creates a new user, and you guys weren't supposed to do that. I've seen that happen before plenty of times. What you'll do is you'll find the CSS attribute that is for that button that you don't want it to touch. You're going to add it into here, and then that's going to save you time on your scan, and then it's also not going to make your admins upset. Sorry, I just stopped myself from vanity there for a second. It's not going to make your admins upset. Yeah. All right. So the last thing that I'll point out is that we've got a lot of different plugins, and these plugins are tests. So each of these tests is great test. I fully recommend that you throw the kitchen sink at it. That way you're doing a full assessment. But if you're trying to work this into the SDLC, it's obvious that some of these are going to take longer than others. So for example, anything that is time-based, anything that is differential. So we're looking at, this request versus that request. That's going to add a lot of cycles onto the individual scan. So maybe you come in here and say, my barrier to entry, the scan that we're going to have in our SDLC is going to just run a few sets of plugins instead of all of them. For example, maybe you'll take out the file inclusion, maybe you'll take out the injections, and maybe you'll also take out the cross-site request forgery and the code executions. These are the plugin families that tend to take the longest, right? But on the flip side, from a security aspect, your security engineers are going to be sitting there going, you're accepting way too much risk. So instead of just accepting all risk, what you're going to do is you're going to put this kind of a scan into your SDLC pipeline. So instead of having a 5-hour scan, we're going to come back and we're going to say, hey, just enable these plugins. And not only that, we're actually going to limit it to just 15 minutes instead of letting it run for hours and hours and hours, because the vast majority of vulnerabilities are actually found in the first 2 to 3 hours anyways. And if you're limiting the scope, you're actually going to find a lot of those header-based vulnerabilities within the first few minutes. So start tuning the scan like this. And this is a scan policy that you can now move into the SDLC. So you're going to save this particular profile. If you come up here, you'll see this config ID. And I've already run my scan, so I can change the APIs as well, the API tokens rather. So if I go back, go ahead, yeah.
Before you jump into that, I just wanted to confirm the plugin families. I saw numbers. For each of those families, what does that constitute? Like,
that's just the number of tests that exist under that particular family. So for example, for component vulnerability, there's a lot of vulnerabilities because this is like your WordPress, Node.js, version, that kind of a thing.
Okay.
This is OWASP A9, if you're familiar with the OWASP groupings. But let's say I've got code execution. There's not 500 types of code execution, right? It's, hey, we've got these different types, and then each one of these may then in turn run 500 different tests against each page, because code execution, again, maybe we find 10 parameters that we want to mess with and play with that we can potentially inject. We find 10 things on the page that we can play with. It's going to play with each one of those, but it's going to play with each one of those with multiple payloads. So that's something that could take a long time. Make sense?
Excellent. Yep.
Yeah, perfect. So you're going to be playing with these different plugins or the tests. You're going to try and make something that's going to be acceptable to the dev team in terms of time constraints. How long is this going to take? But is likewise also acceptable to the security team, so that you're weighing that the scales of security, I guess. All right, so I need to test in X amount of time, but I also need to test as deep as possible. So this is something that it's going to be a lot of give and take. What this policy is going to look like, and then what you'll do is you'll go back and you'll take that configuration, and then that's what you put into here. So when you're going to make your API call, you can see that I'm making the API call right here to this particular string. You can just paste in whatever the string is that you want to run instead, and that's all you have to do. Again, the actual API call itself, we got that from the developer portal. So again, I just stole that right there. You just fill in config ID with whatever the config is, and if you're still not sure where to put it, again, just post it into there, and it'll actually, in real time, post it into the actual portal itself. So let me blow that up for you a little bit. Actually, it doesn't blow up. That's right. Okay, so that's how you're going to work this into the SDLC. DAST, it's kind of square peg into round hole kind of a deal. But just to kind of round out the conversation, let's kind of go back and let's kind of talk about this. Kind of the key takeaways here. The tuning is required for most scans that you guys have. It's not a push button kind of a solution. DAST in general. Each application is its own special little snowflake. Depends what it's made up of. Depends how big it is, how many pages you get, how much JavaScript you got on the particular front end. Lots of things to balance out when it comes to tuning your scan to make it run faster. As well, so this is also something where we need the devs to kind of step in and kind of help shepherd this. because on the security engineer side, a lot of security engineers, they're the ones that are getting this product for their developers, but they don't know how to insert this into the SDLC. A lot of them don't know Python. A lot of them have some basic scripting skills, but a lot don't. A lot of them, are really good at, writing things into a checkbox and say, hey, I'm a great auditor. But a lot of them might not have the technical capabilities to do this kind of thing.
So this goes back to the whole old adage of like everybody being a stakeholder with security.
Yeah.
It's not just the security team. The entire organization has to, basically participate in that.
Completely agree with you there. I know it's now that you bring it up, I should have brought that up. Man, no. Now you're definitely the hero there. Trust me. Like, if I could hit one thing over everybody's head with a hammer, it's everybody's invested in security or needs to be invested in security. It's everybody's job. So the last thing that I'll just say is that SDLC, it's not an obvious fit. So the DAS scans can take a really long time, even against smaller applications, and even when it's in a limited scope. So the tuning is going to require some of your time as a developer. But once you've got that configuration created, that can then just be looped in. You've already got the scan created. You don't have to then go back and continuously tweak it in the future, unless you go through a major application overhaul or something like that, in which case you should probably revisit the policy and make sure that it's appropriate for what you guys are trying to do. So if we can enable you guys to put DAST into the SDLC, hopefully that helps to break down the silos between you guys and your security teams, if those silos are still there. It'll also reduce your time to get security in, because a lot of times as it stands, the security team is left with scanning maybe a production application midnight on Saturday, because that's all they've got, right? They don't know how to inject this into the SDLC, but hopefully after this talk you guys feel confident enough to go ahead and do that. We've got a lot of resources, a lot of scripts and codes that are already pre-built, and I'll walk through those here in a second. But the last thing that I want to mention is what Tenable does is, in addition to trying to work this into the SDLC, we'll use something like Amazon CloudWatch to generate a time-based event every 4 days to say, hey, spin up our QA environment and then scan it. And then we take that information, and again, you could either do a manual check, your security team could do a manual check, or you could pull that into a third-party tool, something like that. So the last thing that I want to go over now is going back into the developer portal. Sorry, this is what I want to go to. So again, we've got a great interface for you guys to go into, a great developer portal for you guys to interact with, so you guys can see, all right, so this is how I would pull vulnerability data after I've launched the scan, because Will, gave us a script to launch the scan, but how do I pull the results back? Well, all those API calls are right here, and so those are, pretty straightforward. But let's say you want to do something a little bit more complex. We've got a few additional resources for you. And if I go to Tenable's Kit, two of the things that I want to call out in particular, so related to what Tim was talking about, we've got this guy called Tenable, and it's a Pythonic interface for Tenable IO and Tenable SE. So the idea is that you've got some commonly used actions that you want to automate via the API, because you're a dev or you're a sysadmin, and you don't want to have to go into a new interface. You don't want to have to deal with Tenable's interface in addition to the 50 others that you guys have. You guys want it in one place where you guys already are. A lot of those actions that Tim went through already, like again, remember those guys can be done via the API, but sometimes it requires like 3 or 4 or 5 API calls strung together. I wonder if somebody's already built something that will do that for me. And the answer is yes. So we've got this guy right here to go through that. We've also got another tool called Navi, which does something very similar. Helps to fill any particular gaps that you guys may find. Let's say that you guys want to have a button that does A, and Tenable doesn't have a button that does A. You could use our Tenable, or you could use the Navi tool to do a lot of that. Or you guys could build it yourselves, depending on your comfort level with doing that. But I also want to point out that we also have a WAS action for GitHub rather. So with this GitHub WAS action, you can actually specify in here the config policy, your access key, and your secret key for those API calls. And then you can also tell it, if you want it to pull for results after. So remember I said earlier, that would be a separate API call, but that's actually all built into this action right here, where it's going to go launch the scan, and then it'll start polling for results, and then it can pull the results down once the scan is complete. And again, you can take that and then push that into something else.
Will and Tim, there's a question here
Sure.
from the audience. So is this part of the Tenable IO product or also Nessus?
That's a great question. So most people know us as the makers of Nessus, right? Renaud Dresson, the founder of Tenable, or one of the founders of Tenable, and and our current actually CTO, the guy that's been our CTO the entire time, they created Nessus. Nessus has been a tool that's been in the industry for years, for decades now. So a lot of people hear Tenable and say, what is Tenable? So we are the creators and makers of Nessus, and in the bottom left-hand corner, you'll see Nessus, and then you've got Nessus Network Monitor, Tenable OT, we've got container security, we've got web application scanning, and we've got PCI ASV. And these guys are all various modules within, these are components within Tenable IO. We actually, we've got one missing here, I'm sorry. We acquired a company this week that does AD security also. So we now have Tenable.ad in addition to this list right here. Sorry, omission there. But yeah, so this would be a part of Tenable IO. So if I go back into Tenable IO, you see over on the left-hand side, we've got this guy called Lumen up at the top. That's kind of a big data aggregator, which it kind of looks at all the data. I guess the best way to put it for people that aren't in security is it looks at all the various security data that we have, and it helps you guys prioritize exactly which vulnerability on exactly which asset, and then kind of metricize, quantitatively state what your cyber exposure and cyber risk is. Thanks, Rob, for posting that. Okay. All right, so that wraps up my portion of the presentation. I'll go ahead and stop sharing unless any other questions come through.
Thanks, guys. Tim and Will, I think I came away with a lot of stuff to learn and kind of go back and try this out myself, really. So just to recap what we've kind of gone through today, if you have unfortunately joined us at this moment, we are closing in at the end of our Twitch show, but we are here at Howdy Partner, highlighting or showcasing what our wonderful partners are doing out there, creating solutions for y'all, essentially, and the other customers out there. And today we had Tenable. First, we had Tim talk about different scanners, including Nessus suite of AMIs, the agents, and the frictionless. And then we just had Will talk about DAST and SDLC portion of Tenable. So before we end, if you have any more questions, now would be the time to kind of get those in one last time. But yeah, this pretty much wraps up our session with Tenable. So Tim and Will, again, I appreciate you both for coming on and endowing us with the knowledge. Just to kind of recap.
Yeah. Just to also jump in here. There is a question, but I'm just gonna go ahead and share my screen because I think my screen will actually share properly this time around. But yeah, just want to go over the integration we talked about previously. So in terms of the integration on Security Hub, once you have your Security Hub set up, you're getting results.
We see your screen with the Twitch show, so you might want to.
Okay, well, that's not what I wanted to share. Yeah, just 1 second. What do you see now? Well, just just forget that. But essentially, I just wanted to touch base on the integration that is with Tenable and AWS Security Hub, where you can receive findings on the Security Hub console and subsequently take action based on those findings as well.
Sounds good. And let's address that question. We have one last question of the chat. So from an SDLC perspective, the audience is still curious about defining triggers to make a job fail. Some vulnerabilities are acceptable use. So would he have a way to say, let's say if you find any vulnerability above a CVS score of X, fail the job?
Yeah, absolutely, and that's something that again can be done through some scripts that can be pulled into Security Hub, for example. So if you want to pull that data into Security Hub, you can say, "Hey, fail anything with a CVSS score over X." And so even if something does not have like an official CVSS score like out there in the wild, we will assign a CVSS score just because that way we can relate it to the relative vulnerability levels. So when the CVE gets published, that there's CVSS score that's associated with it. But if something doesn't have a CVSS score, we still have to give it high, medium, low, informational, that kind of a deal, or critical even. So you can absolutely be as relaxed or as stringent as your pipeline demands. I realize that was a super consultative answer. Like, yeah, do what you want. But yeah, you can say anything that's a critical or anything. One of the things that I think is really easy to put into that pipeline is, remember OWASP A9 is the component-based vulnerabilities. If there's a component-based vulnerability, put a blocker in there, because A, you should have found that with your SaaS tool or SCA tool. Like if you're using Sneak in there or something like that, great. But if you're not, and you didn't find it, and we find something, you should block it, because that's one of the easiest things in the world to fix. It doesn't require you going in and saying, crap, how do I fix this SQL injection vulnerability? The component-based ones are usually like, just upgrade your darn library, something like that. So it depends on your environment. Hopefully that was helpful as to the kind of discussion that you should be having internally with what is an acceptable risk in order to allow it to be pushed.
Sounds good.
Yep. Thank you very much.
Yeah, no problem.
And just to kind of wrap everything up as sort of a call to action. So and I think we covered this earlier, but if the audience or developers who might be watching the show now or on demand, they kind of want to get started, is it just as easy as just getting a trial account on Tenable?
Yeah. So for folks that are new to Nessus, or even just like vulnerability management in general, you can always get a Nessus Essentials. It's like, I think it's like a 8 to 16 IP license. It's free for home use. Download it and scan your network. Start there. Figure out, manage your network as you would a security professional, right? That's your home network. Protect your home network. Start there. So you can scan it, do authenticated scans, scan devices on your home network, all that good stuff. And then if you want, you could take that base scanner, standalone scanner, and link it up to something like Tenable.io. Just go to tenable.com/try. And from there, you get a full enterprise scale license of Tenable.io. Everything's turned on, inclusive of the things that Will talked about today with web app scanning, same as stuff that I talked about. So if you want to kind of get crazy or just get some hands-on keyboard experience, definitely encourage you guys to do that. Usually it's about 24, 48 hours from the time you request it. Somebody will reach out to you, give you a link to register, and then you can hit cloud.tenable.com, link up any scanner, and start firing away and finding vulnerabilities. So
excellent. So audience, if you heard that, feel free. I highly encourage you to try these things out and see them for you in the action. And for more information around frictionless assessment, I posted some links on the chat. You can kind of read up on it a little bit, maybe get further educated on that, as well as web application scanning that Will suggested a couple of the GitHub repos there as well to check out for you. So with that, we can pretty much call this a wrap. So before we go, this is what we like to do at Howdy Partner. We have this sign-off phrase, I guess, we choose. And I'll leave it up to you guys at Tenable. You are to pick one of these three phrases. They are giddy up, y'all come back now, and happy trails. So
This is a big decision, Will. I don't know, man.
yeah, this might be the hardest decision of the day.
I was hoping for Utah, but
Yeah, it's over
it's
here.
unfortunate.
I would say y'all come back now. You hear?
I'll come back now here.
Okay, well, we have a consensus. So before we do that, just want to again appreciate you guys for coming on. Appreciate the audience for joining us today. Again, Howdy Partner is on every Wednesday, 2 to 4 p.m. Pacific time. So next week, come back and just watch another episode. And I hope you have a great rest of the day. So with that said, on a count of 3, I guess y'all come back now is the choice.
Let's do it.
Okay,
Yep.
sounds good. All right, 3, 2, 1. Y'all come back now.
now. You heard?
Y'all come back now.
Thanks, guys, and take care.